know what a sliding rule is for. Well, I do know what it was too. This one could be with you. What a wonderful world this would be. Welcome back, everybody. I hope you are all doing well. Good afternoon. It's Mr. K's 30 Minutes of Math. I'm a little bit more dressed up today. I had a TV interview earlier, so I've got my tie on, but no difference. Ready to rock and roll with our math today. So let us dive in, starting off with our riddle for the day. Let me shut the video off so I can focus a little bit more. As you may recall, we had this triangle with a series of numbers, and the question is, what is the next line? And you might have noticed that there is a bit of a pattern here. And if you have noticed the pattern, you should be able to determine what the next line is. So let's look through it. Starts with 1, and then we have 2 more 1s. But then something starts to change. We have this 2. Then we go to 1, 3, 3. And then we go to 1, 4, 6, 4. We have 1s all the way down on both sides. So anybody have a sense of what would go in the green lines at the bottom? If you think you were able to figure it out, go ahead and type it into the chat window. I'm going to erase all this so we can focus a little bit more. Delilah writes in 1, 5, 10, 10, 5, 1. So let me put that in here. 1, 5, 10, 10, 5, and 1. Well, let's do a little drum roll and see if she has it. Well done, Delilah. You are exactly right. This is a famous triangle called Pascal's triangle. Pascal's triangle, named after Blaise Pascal. Now, I may not be saying that exactly right. It's a name of a French mathematician from almost 400 years ago, 1623 to 1662. And what's going on here is we are adding the numbers to get the numbers in the next line. So, for example, 1 plus 1 gives us 2. And then 2 plus 1 gives us 3. And 2 plus 1 over here gives us 3. Let me erase those. That's kind of hard to see. And then 3 plus 1 gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. And if we keep going, we'll see that 4 plus 1 gives you 5. 4 plus 6 gives you 10. 6 plus 4 gives you 10, and 4 plus 1 gives you 5. Well done. Here's my question. What would, let's see, if the red lines are next, my question is, what would be even after that in the blue lines? Go ahead and take a minute to work on that. We'll be right back. I'll give you a little bit of music.
Okay, welcome back, everybody. Let's see how we did. I see some folks are writing in. Well, let's start with our red lines. We'd start with our 1, as we have always. Then 1 and 5 gives us 6. 5 and 10 gives us 15. 10 and 10 gives us 20. 10 and 5 gives us another 15. 5 and 1 gives us 6, and then 1 again. Excellent job. And then what comes after that? 1, 7, 21, 35, 35, 21, 7, and 1. You'll notice there's some really cool patterns going on here. Look at this right here. You'll see the numbers go up. 1, 2, 3, 4, 5, 6, 7. What is the pattern going on? I'm going to circle in green. What's the pattern going on here? Anyone can figure out? This one, the green one. Can anyone figure out what is the pattern in this green section that I have highlighted? It goes 1, 3, 6, 10, 15, 21. What do you notice about the pattern there? It's super cool. Anybody have any ideas? Well, I'm going to write it out here. 1, 3, 6, 10, 15, 21. Donna writes, you're adding up 1 more. That's basically right. From 1 to 3 is +2. From 3 to 6 is +3. From 6 to 10 is +4. 10 to 5 is +5. And 15 to 21 is +6. All right, well done, guys. You did a fantastic job. All right, let us move on. This was last night's homework, if you recall, and I'm sure you all did it, but in case you didn't do it, no problem. Let's take a look at it right now. We have fourths, sixths, thirds, 12ths, and 24ths. So I think I'm going to decompose my fourths, sixths, thirds, and 12ths into 24ths. So follow along with me as I do this. Delilah already has her answer in. Let's see what we have. 3/4 is how many 24ths? Well, we're going to multiply by 6. So that gives us 18. All right. 1/6 is how many 24ths? Well, I'm going to multiply by 4 here. So that gives us 4. Then 2/3 is how many 24ths? Well, that would be multiplying by 8, which gives me 16. 4/12 is how many 24ths? Well, that one to decompose, we multiply by 2, which would give me 8 24ths. And then last we have 7 24ths, which is 7. So I have 18, 4, 16, 8, and 7 24ths. All together, that would be 18 plus 4 is 22. 22 plus 16 is 38. 38 plus 8 is 46. And 7 more would give us 53 24ths. Okay, so let's see what we've got. That's a lot of 24ths. Well, we know, let's do some number bonds. 24 24ths, that's 1 whole. And another 24 24ths, that's 2 wholes. That would be 48, which means we'd have 5 24ths left over. So 2 and 5 24ths. Delilah, well done. I'm giving you a big round of applause. Fantastic. Whew, that was a lot. But I am very, very pleased to see that you got it. And Donna wrote in that she got it too. Fantastic. All right, let's move on. I would like you to take a second and think. You shouldn't have to write anything. Just if you think for a second, what would go in the missing numbers in the lines. So go ahead and think for a second, what should go right here where I'm putting the question mark? You shouldn't have to do any math if you're just thinking about the fractions for a second. What should go for that blue question mark? 4 and 7/8 plus question mark would give us 5. What should go right there where the question mark is? Anybody have any thoughts about that? 4 and 7/8 plus question mark would equal 5. Well, let's take a look at it. 4 and 7/8, and we have 5 over here. Well, how much more are we going to need to get from 7/8 all the way to 8/8, which would give us another whole? And if we add that to our 4, we would have 5. Well, to get from 7/8 to 8/8 is just 1/8. Well done. All right, how about B? 7 and 2/5 plus what would get us to 8? We have 7 wholes and 2/5. 7 wholes and 2/5. We want to get over to 8. Well, we have 7. How do I get from 2/5 to 5/5, which would give us another whole? What do I need to do? I need to add 3 more fifths. Well done. C, I see some folks writing in already. We have 3 holes on one side, and on the other side we have 2 holes and 1/6. So to get that 1/6 to turn into 6/6, which would give us another hole, we need 5 more sixths. And last, we have 12 holes on one side. The other side, we have 11 holes and 1/12. To get that 1/12 to turn into 12/12, which would be another hole, would be 11 more 12ths. Well done, everybody. All right, I am gonna skip this and jump right to our more complicated comparing of fractions. So we did this a little bit before, but now we have some more complex numbers. It says plot the following points without measure. List the fractions in order from least to greatest. So we're going to start with 2 and 7/8, and I'm going to do my blue section and my red section. 2 and let me do this. Let's add a yellow section and a green section. All right, 2 and 7/8. Where does it go? In the yellow section, the blue section, the red, or the green? 2 and 7/8. What do y'all think? 2 and 7/8. Yellow, blue, red, or green? Which section makes the most sense for 2 and 7/8? Well, it's more than 2, and it's almost at 3 because we have 7/8. So I'm going to say it probably goes right about, how about I'm gonna use orange. I'd say it's almost right here. Whoops. 2 and 7/8. Then we have 3 and 1/6. Well, it's more than 3. It's definitely less than 4. And we only have 1/6. So I'm gonna say right about there, 3 and 1/6. And then 29/12. All right, let's use some number bonds. 12/12 is 1 whole. 12/12, that's 2 whole. That would be 24. And then we'd have 5/12 left over. So 1 whole, 2 holes, 2 holes, and 5/12. Interesting. Well, what would halfway between 2 and 3 be? It would be 2 and 6/12. We have 2 and 5/12, so it's a little bit less 2 and 5/12. All right, well done, well done. Go ahead and take a second and do B. Go ahead and take a second and do B. We'll be right back. Okay, welcome back. Let's see, 29/12. That was this guy right here. And 2 7/8 right here. So we know 29/12 is less than 2 7/8. Then 29/12, again, that's this one. And 3 1/6, that's this one. 29/12 is less than 3 1/6. Well done. I see Delilah wrote in. Fantastic. Okay, math joke of the day, everybody. Here we have it. What did the pet store owner say when she saw her favorite parrot was missing? Let me give you a little Jeopardy on that one. Okay, are we ready? Here we go. What did the pet store owner say? The pet store owner said, polygon. Get it? Poly is the name of lots of birds. Polygon means a shape with many sides. Poly equals many. Anybody know what a polyglot is? A polyglot is someone who speaks many languages. That got me thinking about different prefixes that mean numbers, particularly for shapes. Yes, Delilah, I know it's a groaner. I'm sorry about that. Well, whoops, coming back. Let's look at some of our prefixes. I'm going to start here at pentagon. It has 5 sides. The prefix penta means 5. Hexagon has 6 sides. The prefix hexagon, hex means 6. A heptagon has 7 sides. The prefix hept means 7. Octagon means 8 sides. Oct, which is the same prefix that you hear in the animal octopus. 2, 3, 4, 5, 6, 7, 8. Nonagon is 9 sides, and decagon is 10 sides. So those prefixes are really, really helpful to know, and they show up in lots of different places, plus lots of other prefixes. So sometimes you'll see Greek prefixes, sometimes Latin. The ones we just did, penta, hexa, hepta, octa, deca, and enea, though we kind of write this as nona. Those are Greek, and they have Latin peers. Whoops, sorry about that. Quin for 5, sext for 6, sept for 7, oct for 8, which is about the same, novem for 9th, and deci or decem for 10th. So here is my question for you all. Let's take oct. So octo, like octopus. Think about the month October. What month of the year is it? Think for a second and tell me, what number month of the year is it? Is it the 5th month, 7th month, 10th month? What number month of the year is it? Go ahead and think. Donna writes in the 10th. Let's see if she's right. January, February, March, April, May, June, July, August, September, October. She is right. It's the 10th month. So my question to you is, what Why is it the 10th month, but it has the prefix for 8? Similarly, September should be the 7th month, but it's not. It's the 9th month. What is going on here? What is going on, my friends? Well, there's something very interesting that happened in history. I'm going to show you. We started with a calendar in the Western world anyway, called the Roman calendar. It was used in Roman times. And the first month was March. And it was honoring the god called Mars. Then April, honoring Aphrodite. Then May, honoring Maya. Then June, honoring Juno. Then July, you'll begin to see our prefixes. Quintilis is what it was called. That's the prefix for 5. Then August, sextilis for 6. September was September for 7th. October is oct for 8th. November, NOV for 9th. And December, DEC for 10th. Everything was perfect. Yay, the numbers lined up. But one problem. The year didn't quite work out. There weren't enough days in the month, in the year. There were only 304 days, and we know a year is 365 and about a quarter days. That's the time for the sun, the earth, to go all the way around. Here's the earth. Go all the way around the sun. So they needed to add some time, and that is exactly what they did. When Julius Caesar, anyone ever heard of Julius Caesar? In 45 BC, Julius Caesar introduced a new calendar, which he named after himself, called the Julian Calendar. And it included 2 more months, January and February. And so we ended up with this calendar, which you know today. Here's January and February. So March, which used to be the first month, now became the 3rd month. April was the 2nd, and it became the 4th. And we work all the way down. So October, which used to be the 8th, which makes sense, it became the 10th month. Same with November, August, September, and so on. I think that's pretty cool. Just a little bit of history for your mathematics today. All right, let us move on to do a little bit more comparison of fractions. Go ahead and take a second. Use any strategy that you would like to put your less than or greater than signs. Right now, I'll give you a little bit more beautiful music. Okay, welcome back, everybody. Let's take a look at these. Starting with A, we have 6 1/2, and we have 6 3/8. Well, we have 6 on both sides, so I'm gonna just cross them out because that we know is the same. So all we're really looking at is 1/2 and 3/8. 1/2, if I decompose that half into eighths, we would get 4/8. 4/8 is greater than 3/8. There you go. Next, we have 7 and 5/6 and 7 and 11/12. Again, we have 7 on both sides, so does it really matter? No, we can just cross those out because that's the same. Really, all we're talking about is 5/6 and 11/12. Let's decompose those 6 into 12ths. And we're going to get 10/12. So we know 5/6 is less than 11/12. Well done, Delilah, so far. For C, we have 3 on this side and 3 on that side. So we can cross those out. Those are balanced. Those are equal. Then we have 6/10 and we have 2/5. Let's compose our tenths into fifths. Remember, when we compose, we're going to divide. That would be 3/5. Well done. 6/10 is greater than 2/5. And then last, we have 2 wholes again on each side. So we can just cross those out. Those are already balanced. And then we have 2/3 and 8/12. Let's decompose our thirds into 12ths. We can do that by multiplying by 4, which gives us 8/12. And there you have it, equal sign. Well done, well done. Very, very impressive work. All right, we have one more comparing fractions here. We have a couple minutes, so go ahead, quickly do those. I just realized Delilah wrote in, yes, these are exactly the same. I'm so sorry, guys. My apologies. Let's go straight to our homework for tonight. Here you have some missing numbers to make these addition sentences true. Go ahead, take a picture or write it down so you have these for tonight. Before we get to our riddle, well, actually, you know what? I'm going to jump into the riddle because it does take a little bit of explaining, and I want to make sure that we got that right. So again, take a picture, take a screenshot, or write down tonight's homework so that you can take a look at it tonight. All right, let's go on to our riddle. Here it is. If you have 5 people, 5 people in a room. Now let's make sure they're all standing 6 feet apart and wearing gloves and masks, given our current coronavirus situation. And each person shakes hands with every other person in the room exactly once. How many handshakes would occur? So I want to just give you a quick example. Let's say we had 3 people in a room. Whoops. We'll have the blue person, the green person, and the red person. And they each shake hands with each other once. Well, the red and the blue person, that's one handshake. So red has shaken hands with blue, blue has shaken hands with red. So that's 1. Here's 2. Red has now shaken hands with green and blue, so red's done. Green has shaken hands with red, but not with blue, so let's add that one. That's 3. So green is done. And is blue done? Well, blue has shaken hands with red, and blue has shaken hands with green, so blue is done. So if we only had 3 people, it would be 3. Now I'm going to tell you the answer is not 5, but I wanted you just to look at a model to help you think about how to approach this. I'm going to give you a hint. It is more than 5. All right, go ahead and work on that tonight. Give it a try. Hopefully you'll come up with a good answer, or at least just struggle with trying to find the answer, which is just as important, to stretch your brain. Can't wait to see you all tomorrow. Have a wonderful afternoon. Bye, everybody.